Hello and welcome to our third lesson in Chapter 7b on how do we solve inequalities. If you would like to pause the video to give the do now a look, please do so now and resume when you would like the answers. Alright, let's go over the do now. A. Match each of the following inequalities with the correct graph. Number 1, x is greater than 4. Well, using process of elimination, I'm going to recognize that just the greater than symbol means I must have an open circle. So that can't be A or D. And then a greater than symbol means we are pointing in the right direction, a ray to the right, which must be letter B. Number 2, x is less than 4. Using that same thought process I did in number 1, has to be an open circle, and the only other choice here with an open circle is choice C. It's got to be that. And it's also pointing to the left. Number 3, x is greater than or equal to 4. So we know it needs to be a filled-in circle, which is either A or D, because it's greater than or equal to, and this inequality graph must be pointing to the right, which is letter D. That means number 4 must be A, but just to check and make sure, less than or equal to 4, we must have a filled-in circle at 4, which A does certainly have, and the ray pointing to the left. Letter B, solve the following equations. 3x equals 18. This is a review from our past unit. We know to solve this equation, we must isolate the variable. So we are going to use the inverse operation of multiplication, and let me zoom in here, and divide both sides by 3. In doing so, x equals 6. And next question. B, x plus 5 equals 17. We're going to use our inverse operation of addition and subtract 5 from both sides. In doing so, we get x equals 12. Awesome. Now for some notes on how we go about solving inequalities as opposed to equations like we did in the do now. We actually solve inequalities the same exact way that we solve equations. You're going to use the same strategy of, let's see if I can zoom in here, of isolating the variable by using inverse operations. So same thing, we want to get that variable totally alone. For example, if we're going to solve w plus 5 is greater than or equal to 8, we are going to use the following steps. And then in this example, we're going to graph our solution. So number 1, write the original inequality. We have done so to the right over here. 2, we are going to, in order to isolate that variable, we are going to subtract 5 from each side. Let me write that down on the blanks. We are going to subtract 5 from either side. So I'm going to show you me doing that in the example. We're going to subtract 5 from both sides. And then we're going to simplify. When I subtract 5 from both sides, the 5 goes away on the left-hand side of the inequality symbol, and 8 minus 5 is 3. So we get our answer of w is greater than or equal to 3. So I didn't do anything that was that radically different than how we solve equations. The only thing that's different here is instead of an equal sign, it's just going to be a greater than or equal to sign, or it could be any of our other inequality symbols. So let's graph this solution. We know how to do so from yesterday's lesson. W is greater than or equal to 3, so we're going to place a circle directly above where our solution is. So we have our solution at 3, so I'm going to put a circle above 3. This circle needs to be filled in because it's a greater than or equal to sign. And then we say to ourselves, okay, for a greater than or equal to sign, which way does my arrow need to point? It's going to point to the right. So I'm going to write that onto my graph. Awesome. And lastly, yes, you must check. To do so, choose an integer that satisfies the inequality W is greater than or equal to 3. So we're going to think about an integer that we know satisfies that inequality. What's a integer that is greater than or equal to 3? Well, I think the easiest one for this particular example would be the number 4. It's the first number that is to the right of 3. So we're going to now write the original inequality for our check. We have done so. And we're going to substitute in that value that we know satisfies the inequality. So I'm going to substitute 4 in for W. So W is now 4. I'm going to rewrite everything else. 4 plus 5 greater than or equal to 8. Now, is the inequality true? Well, what's 4 plus 5? It's 9. Greater than or equal to 8. Is 9 greater than or equal to 8? Sure it is. We have satisfied our check. Not the best check symbol, but you get the point. Good. Super. Time to practice some questions together. Number 1, we're going to solve the inequality and then graph the solution. So number 1 says x plus 7 is greater than 11. So we are going to solve this inequality just like we would if there was an equal sign here. So I'm going to isolate the variable using my inverse operation. The inverse of addition is subtraction, so I'm going to subtract 7 from both sides. In doing so, we get x is greater than 11 minus 7 is 4. So that's the solution to this inequality. And now we're going to graph that solution. Head over to my graph. Awesome. So I'm going to place a circle above the value of 4 once I've placed my values on my number line. We know we're going to put 4 right in the middle. 5, 6, 7, 3, 2, 1. So here goes a circle above my solution of 4. It does not need to be filled in because this is just greater than, not greater than or equal to. And my solution is going to be pointing to the right because it is a greater than symbol. Number 2, 4f is less than or equal to 0. I'm going to use my inverse operation to isolate the variable. 4f, that is the operation of multiplication, so I'm going to divide both sides by 4. The 4's will go away, and f is less than or equal to 0 divided by 4 is 0. So f is less than or equal to 0. Now time to graph my solution. I'm going to put some number values onto my number line, starting with 0 right in the middle. 1, 2, and 3. -1, -2, -3. We're going to put our circle directly above 0. And that circle needs to be filled in because it is less than or equal to. And we are heading this time to the left because it is a less than or equal to symbol. Good. Number 3. In order to raise money for team towels, your swim team decides to sell pizza. Yum. The profits are $2 for each pizza. Write and solve an inequality to determine the number of pizzas you must sell to have a total profit of at least $75. So, we're going to first write an inequality that's going to represent this situation. So we are getting $2 for each pizza. Keep in mind the words for each mean the operation of multiplication. So it's $2 per pizza. So you are getting $2 per pizza. So 2p can represent the multiplication between $2 and p for each pizza that you sell. Now, the other side of this is that we want to have a total profit of at least $75. So at the minimum, the team here, is that what the situation is? Yes, for Team Terrell's, your swim team. The swim team wants to have at least $75. So we need to make $75 at minimum. So selling these pizzas, we must make greater than or equal to $75. Now time to solve the inequality. So we are going to isolate the variable by using the inverse operation. We're going to divide both sides by 2. P is greater than or equal to. 75 divided by 2, I'm going to use some mental math, is 37.5. If you needed to do the division on the side, that's fine. So P must be greater than or equal to 37.5. Remember what P stands for. It's pizza. So you must sell at least how many pizzas? Well, we're going to consider that you're selling whole pizzas. So the first value that's greater than or equal to 37.5, the first integer value that's greater than 37.5 is 38 pizzas. So to answer this question, you must sell 38 pizzas. Good. Now it's time for you to try. Now would be a good time to pause the video, try numbers 4 and 5, and then resume when you would like the answers. All right, number 4, solve and graph. So we have the inequality 3 plus j is less than 6. I know a lot of students will like to rewrite this inequality as j plus 3 is less than 6. The reason why you're allowed to do that is because of the commutative property. Addition is commutative. You do not have to, though. We can use the inverse operation of subtraction to subtract 3 from both sides so that j is less than 3. Let's head over to our graph to look at what that looks like. Going to place the number 3 in the middle. 4, 5, 6, 2, 1, 0. I'm going to place a open circle above 3. That is going to stay an open circle because it is less than. And the less than symbol says we will point to the left. And that is the answer to number 4. Number 5. Mr. Levinson is ordering t-shirts for RISE participants. He has already received orders for 45 t-shirts. If he gets C more orders, he will be eligible for a discount. C more orders. More to me is screaming addition. The company gives a discount for orders of more than 60 t-shirts. Write and solve an inequality to determine the number of additional t-shirts needed to be ordered to get the discount. So, Mr. Levinson has already received orders for 45 t-shirts. If he gets C more orders, so more is plus, we'll do C for more orders because that's the variable they tell us to use, he'll be eligible for a discount. If and only if there are orders for more than 60 t-shirts. It's got to be more than 60. So that's greater than 60. Can't be greater than or equal to. It has to be more than 60 t-shirts. Now let's solve this inequality. We're going to subtract 45 from both sides. And c is greater than 15. Which means we must order, Mr. Levinson must order more than 15 more orders of t-shirts in order to get that discount. So to answer the question, at least 16 more t-shirt orders are needed. And the answer is 16 because that is the first integer that is greater than 15. And since our inequality solution was c is greater than 15, the first integer greater than 15 is 16, which is how many t-shirts must be ordered in order to get that discount. Very nice. Let's briefly summarize. Compare and contrast solving an algebraic equation and an inequality. So I'm just going to put down 2 bullets here. Firstly, they both use inverse operations to isolate the variable. So once again, that's a major similarity between how we solve algebraic equations and algebraic inequalities. You need to isolate the variable, get that variable alone for both of these types of questions. Secondly, an equation has only one solution. While an inequality has infinitely many solutions. And that concept is really important. When we solve an algebraic equation with an equal sign, when you find the answer to that equation, that is the only solution. But when you solve an inequality, since there is an inequality symbol, for example, like in number 5, we got the answer of c is greater than 15. There's infinitely many solutions to this inequality because there are an infinite amount of numbers bigger than 15. 16, 17, 18, 19, 20, 30, 50, 100, 1,000, a million, on and on and on. So inequalities have infinitely many solutions. All right, and that's it. You are masters of inequalities. You've made it through Chapter 7b. I know it was a quick one, but please feel free to reach out to any of your teachers if you have any questions, and we will see you for the next video. Have a wonderful day. See you next time.